Hi, I'm Angelina Wang, and today I'm going to talk about our work called Measuring Representational Harms in Image Captioning. Image captioning refers to the task of generating a single sentence to describe the most salient aspects of an image. This is an inherently subjective task because of the need to decide what is and is not worth pointing out in an image. For example, the first two captions point out the surfboards in the image, while the last caption does not. Additionally, unlike related computer vision tasks such as object recognition, which typically focuses only on nouns and is constrained to a set of predefined labels, image captioning both generates additional parts of speech as well as uses an open-ended vocabulary, meaning that any word can be generated. These characteristics of image captioning systems create unique concerns when it comes to fairness. First, the subjectivity of the task leaves open room for interpretation that can lead to differential treatment of different social groups. For another, by generating all parts of speech, some adjectives and verbs may be systematically associated with some social groups, but not others. And of course, the open vocabulary makes it hard to anticipate harmful model outputs ahead of time. On this slide, we can see a few different examples of images and their captions that may be considered harmful. In the first, a human annotator has captioned the image a cute little oriental couple sitting at an airport with cameras and smiling, which can be considered a condescending description of the people in the image, as well as potentially offensive through use of the word oriental. Prior work on this topic has largely focused on A, measuring an underspecified notion of bias, as well as B, using measurement techniques that are not well tailored to the unique characteristics of image captioning. For example, a number of works focus on the accuracy of the gender prediction component of the captioning system, neglecting other harms and aspects of the system. However, image captioning systems are composed of a number of different components, like a computer vision and natural language model, that can each individually and collectively bring about fairness-related harms. In our work, we tried to develop an approach to identifying the fairness-related harms of image captioning systems that is more well-grounded in specific normative concerns and more attuned to the unique dangers posed by captioning as a task. To do so, we build on prior work that has identified different types of representational harms, which are harms that machine learning systems can cause when their outputs cast certain social groups in a less favorable light than others, affecting the understandings, beliefs, and attitudes that people hold about members of these groups. In this presentation, I'll focus on two of these harms. When a machine learning model propagates harmful stereotypes about certain social groups or demeans those who belong to a certain social group. To be clear, our work is not an attempt to audit a specific image captioning system. Instead, it is an exercise in responding to the limitations of past work by creatively developing normatively grounded methods, while simultaneously attending to the implications of our own choices, especially the assumptions that we felt we needed to make, but knew would not always hold in practice. Going through this process helped to highlight the serious challenges of developing such methods that we will need to address going forward. Briefly, I will go over how image captioning systems work, specifically the state-of-the-art system that we use in our study. Like most image captioning systems, it takes an image as input. This is fed through a computer vision model, which extracts meaningful visual features, and in our case, labels that capture salient aspects of the image. Then these visual features and labels are fed through a natural language model, which auto-regressively generates a caption for the image. Finally, as a part of our measurement approach, we feed the caption through a dependency parser to generate a scene graph. This allows us to compare captions to labels, as we will explain next. Because of the multimodal nature of an image captioning system, harms can arise from any component individually or collectively. For example, a computer vision model may only treat a soccer ball as salient if it is pictured with a masculine presenting person. A natural language model that starts a caption with a woman may reproduce gender stereotypes, and a system may only mention a paintbrush if it is held by a person with a light skin tone. In our work, we develop a measurement approach based on various stages, which allows us to better understand where harms arise and in turn enables us to understand which mitigation techniques might be most effective. To do so, we rely on 4 sets of data annotations. The data annotations are for 2 data sets, common objects in context, or COCO, and conceptual captions, or CC. The annotations take the form of either labels, for example, sky, blue, ball, or captions, which are full sentences. The first stage we consider is human-generated labels of an image, representing all of the contents in an image that are liable to be remarked upon by the caption. The second is the system-generated labels. Because image captioning systems are often composed of a computer vision and natural language model, these represent the outputs of just the computer vision portion of the image captioning system. Third, we consider the human-generated captions that come with an image captioning dataset. Finally, we consider captions generated by the image captioning system. Certain fairness-related harms, such as the presence of a demeaning word like a racial epithet, can be measured at each of these stages, for example, in the human-generated labels, the human-generated captions, or the system-generated captions. However, other kinds of fairness-related harms, such as whether a caption fails to even mention a person depicted in the image, requires a notion of ground truth to understand whether there was a person in the image that was ignored. Thus, we can compare between these different stages of data to perform those measurements that require some kind of ground truth. And in fact, by using different stages as ground truth when performing measurements at another stage, we can get a better idea of where the harm might have arisen, and thus where mitigation might be best targeted. For example, if we find evidence of a harm at stage 4 of the system-generated captions using stage 1 of the human-generated labels as the ground truth, then these harms could have arisen anywhere from the human-generated captions the system was trained on to both the computer vision and natural language model within the captioning system. However, if we measure the harm now using stage 3 of human-generated captions as ground truth, then we know the harm could not have arisen from the human-generated captions and must have come from the captioning system as a whole. Similarly, if we now use system-generated labels as the ground truth, the harms we measure could not have come from the computer vision model, but must have come from either the human-generated captions or the natural language model. Our measurement approach necessarily involves making assumptions that may not always hold, thereby threatening the validity and reliability of the resulting measurements. We find it important to make these assumptions explicit and to point out when they may not hold. In doing so, we not only hope to make clear the limits of our approach, but to highlight the challenges that other approaches along these lines will have to grapple with. First, a number of our measurement techniques involve several external resources and tools, such as word lists for non-imageable words like vegetarian and an automated tagger for part of speech. As a result, one major assumption underlying our approach is that these resources and tools are themselves valid and reliable. For the word lists, we assume that they are exclusive, so do not contain irrelevant words, exhaustive, so do not omit relevant words, and up to date. In practice, though, language is continuously evolving, so these assumptions likely do not hold. Our next assumption is that we have access to high-quality human-generated labels and captions. Because some of our measurement techniques treat these as the ground truth, we are assuming that they are of a high enough quality to justify this decision. For example, in order to assess differences in treatment between different social groups, we leverage a dataset of demographic labels on the people in the COCO dataset. These demographic labels were annotated by external crowd workers rather than by people in the images themselves, and thus may not be accurate. Finally, we note that the results of our measurements are limited by the coverage of COCO and CC. For example, if COCO contains no images that depict a particular scene, then the measurements we obtained using COCO reveal nothing about how an image captioning system would perform on such images. Given the limited time, we will only go through a subset of all of the measurement techniques that we've proposed in our paper. We will discuss one technique developed to identify and measure stereotype, which are oversimplified beliefs about social groups that reproduce harmful social hierarchies, and another technique developed to identify and measure demeaning harms, which are model behaviors that cast certain social groups as being of lower status and less deserving of respect than others. We perform these on the popular image captioning datasets COCO and CC using captions generated by the VinVL captioning system, which held the top leaderboard score for many tasks, including COCO image captioning at the time of our analysis. First, we will discuss a measurement technique for stereotyping that considers captions that incorrectly include words. We hypothesize that cases where words are incorrectly included in captions, in other words, false positives, may be explained by stereotypes. For example, if a gun is incorrectly included in the caption for an image of someone who is Black, this is likely due to a racial stereotype. To identify cases where words are incorrectly included in captions, we focus on 3 scenarios. The first is where a caption includes a non-imageable concept, such as vegetarian or evil. Our technique is based on the idea that inferring such a concept would require extra information that may come from a stereotype, and we rely on pre-existing word lists of such non-imageable concepts to perform these measurements. The second scenario is where a caption includes a concept that is too specific, again making the assumption that inferring such a concept would require extra information that may come from a stereotype. This includes scenarios like captioning an item that only has enough information to be identified as a hockey stick to be a field hockey stick, or an unidentifiable drink as the more specific soju. The third scenario is where a caption includes an imageable concept that is not depicted in the image, which we refer to as a hallucination, again making the assumption that inferring such a concept would require extra information that may come from a stereotype. The results we will show are from using stage 1 of the human-generated labels as ground truth and measuring on stage 4 of the system-generated captions. In other words, we're using the labels from stage 1 to represent the set of possibilities to be remarked upon by the stage 4 captions. Here are some examples of images surfaced with these techniques. In the first two, stopped and waiting are considered non-imageable, and in the last one, the system generates too specific a description of flat screen for the TV. However, clearly these captions are not actually the result of a stereotype harm. Thus, we find a challenge which recurs throughout our work, distinguishing between innocuous and harmful mistakes. Measuring the extent to which incorrectly included words are explained by stereotypes is challenging because of the amount of contextual and historical knowledge required. As a result, this technique requires human interpretation and cannot be fully automated. In other words, these measurement techniques are best viewed as providing an over-inclusive upper bound. That being said, we do offer a heuristic to make the results of this measurement technique more tractable. Our solution is proposing a heuristic to rank the incorrect mentions by those which are more likely to be stereotypically harmful. Words which are highly correlated with some social groups are more likely to be associated with the stereotype. For example, a case where a baby is incorrectly included in a caption for an image of a woman is more likely to be explained by a stereotype than a case where apple is incorrectly included because of stereotypes about women as children caretakers. The heuristic we employ attempts to capture this correlation. Using this heuristic, we are able to surface incorrect mentions in the captions that are more likely to be due to a stereotyping harm. These are 8 examples of false positives from the system-generated captions on the COCO dataset. The bold word in each caption is an example of a hallucination. In the top left, we see 2 images where a type of Asian food is hallucinated in an image. On the top right, we see 2 images where the system hallucinates a bikini and black dress for images of women who are not actually wearing those items. On the bottom left, we see beer being hallucinated for images of men, while wine is hallucinated for images of women. Next, we will consider a measurement technique for the harm of demeaning. We consider whether people belonging to certain social groups are mentioned in the captions more or less often than others. In this technique, we hypothesize that a failure to mention people depicted in images is demeaning because it is a form of dehumanization. We restrict our focus to images where people bounding boxes cover more than 10% of the image, thereby excluding images in which there are people depicted in the background who are likely not worth mentioning. Because we have demographic labels of the people in the images in COCO, we can compare between people of different social groups. In this case, people of darker skin tone and people of lighter skin tone, and see if they are mentioned at different rates. We use our stage 1 human-generated labels as ground truth and measure at the remaining 3 stages. None of our results are statistically significant, although we note that the human-generated captions yielded the smallest difference between people of darker and lighter skin tones, while the system-generated captions yielded the largest, suggesting that the system as a whole may be amplifying this kind of demeaning harm. In CC, we do not have access to demographic labels, but we can look at some examples of images where the human-generated caption tells us that there is a person in the image, but the system-generated caption does not remark upon them. For example, the stage 3 human-generated caption mentions baseball player prepares to bunt during a season game, but the stage 4 system-generated caption neglects to mention the person, instead saying number of bats during a game against sports team. We also show 3 examples where broken assumptions mean our measurement technique is not actually capturing a mistake we might believe to be demeaning. In the first example, the word pop becomes incorrectly processed to refer to father. As a result, it appears as if the human-generated caption mentions the person, although this is not the case. In the second image, our assumption that the human-generated captions are of high quality does not hold because the human-generated caption for the image refers to the person who posted the image. In the third image, our assumption that there is a correct way to caption an image does not hold because the image is an abstract painting that allows for many reasonable interpretations. In conclusion, in this work, our goal was not to audit a particular image captioning system, but rather show how we use multiple measurement techniques to better capture the multifaceted nature of each harm. Some techniques are best viewed as mechanisms for surfacing when harms might exist as an entry point for further exploration. For example, the false positives and stereotypes, while others are more narrowly targeted and yield measurements that can be taken at face value, such as whether a person in the image was mentioned. However, in all cases, they are intended to be faithful to the underlying harms of concern. The real world is messy, and representational harms are not defined by categorical rules, but rather nuanced extrinsic factors that reflect historical disparities. So any measurement approach necessarily involves making assumptions that may not always hold in practice. Developing normatively grounded measurement techniques that are well tailored to the unique characteristics of image captioning is a very difficult task. That said, we emphasize that it is important to resist the temptation to measure only those properties or behaviors that are easy to measure. Thank you for listening.